On a launch pad in Florida, a spacecraft sits exactly where it is supposed to be. Nothing is moving toward the moon. No engines are firing. No countdown is underway. 3 astronauts climb inside, take their positions, and begin what should be a routine test. The mission has not started. In a technical sense, it does not even exist yet. And yet, this is where the story ends.
We are ready for departure.
The first crew assigned to fly Apollo will never leave the ground. At the beginning of 1967, Apollo represents the future of the moon program. The spacecraft on the pad is expected to carry astronauts farther than any human has ever traveled. Confidence surrounds the project. The dangerous part seems obvious. It lies somewhere ahead, beyond Earth, beyond orbit, beyond the safety of home. The launch pad is supposed to be the safe place. Inside the command module, astronauts Gus Grissom, Ed White, and Roger Chaffee settle into a spacecraft preparing for its first crewed mission. Around them, technicians continue a plugs-out test, a rehearsal designed to prove the spacecraft can operate on its own power before launch. The capsule is sealed. The hatch is closed. The crew waits. Nothing about the scene appears extraordinary. Yet the spacecraft is already becoming something else. Once the hatch is secured, the astronauts depend entirely on the environment surrounding them. Air, communications, electrical systems, procedures, rescue access, everything now flows through a chain of assumptions that must work together. The spacecraft is designed to protect them. But protection is no longer something they control. The cabin is pressurized with pure oxygen.
Step 12.
Ground systems support the test. Outside, personnel remain nearby. Inside, the astronauts continue working through procedures. It still feels routine.
Affirmative, we are still going
Then, small interruptions begin appearing.
Careful with that edge.
An unusual odor draws
that.
attention.
Watching the port side.
Communications become unreliable. Voices break apart. Messages repeat. Delays stretch longer than expected. The spacecraft remains on the pad. The crew remains safe, and each problem appears manageable on its own. Tests experience interruptions all the time. Engineers troubleshoot. Astronauts wait. Schedules slip. No single issue seems large enough to stop everything. But confidence is changing shape. The command module no longer looks like a machine moving smoothly toward flight. It looks like a machine demanding explanations. The test continues. Hours pass. The hatch stays closed. The crew remains inside. What nobody can see is that the story is slowly shifting away from readiness and toward dependency. Because if the environment itself becomes dangerous, every layer surrounding the crew must respond perfectly. And there is very little time available for mistakes. Late in the afternoon, the situation changes in seconds. A voice suddenly breaks across communications. Fire.
Static braking.
Inside the cabin, flames appear within the spacecraft. For a moment, the explanation seems simple. A spark has ignited material inside a pure oxygen environment. Fire spreads rapidly because oxygen feeds combustion with extraordinary efficiency. That answer feels sufficient. A fire caused the disaster. The problem is that the visible reality refuses to stay that simple. The flames are spreading. Pressure inside the cabin is rising. The crew is trapped behind the hatch. Outside, rescue personnel move toward the spacecraft. Smoke pours from openings. Communication fragments disappear into noise. The emergency is no longer ignition. The emergency is escape. Every second removes another option. The cabin pressure climbs so rapidly that opening the hatch becomes nearly impossible. The design requires multiple steps. It was never intended to be forced open against such conditions. Inside the spacecraft, survival time is shrinking. Outside the spacecraft, rescue capability is shrinking. The distance between the astronauts and the people trying to reach them is measured in only a few feet.
Got a major fire in the cabin.
Yet those few feet become impossible to cross before time runs out.
Activate the emergency oxygen.
The hatch eventually opens. But by then, the remaining window for survival is already gone. The mission ends before launch. 3 astronauts die inside a spacecraft that never leaves the ground. In the aftermath, attention naturally turns toward the fire itself. Investigators search for an ignition source. They examine wiring, materials, equipment, procedures, and conditions inside the cabin. The temporary explanation remains convincing. A spark ignited a fire. But another question refuses to disappear. If that explanation is complete, why was survival impossible? The deeper investigation begins revealing a different picture. Pure oxygen did not act alone. Flammable materials did not act alone. The hatch did not act alone. The wiring did not act alone. No single vulnerability fully explains what happened. Instead, the disaster emerges from assumptions interacting with one another. A pressurized cabin.
Agreed.
A pure oxygen environment. Combustible materials. Difficult emergency access. Limited escape options.
Look at the sequence here,
Each condition appears manageable when viewed separately. Together, they transform a spacecraft into a trap. The spark starts the event. The system determines the outcome. That distinction changes everything. The burned interior of the command module becomes more than evidence of a fire. It becomes evidence that Apollo itself is not ready. Before astronauts can travel to the moon, the spacecraft must prove it can protect them on Earth. The redesign is extensive. Materials change. Wiring changes. Procedures change. Most visibly, the hatch changes. A new design allows rapid outward opening during emergencies. Safety becomes a requirement woven through the spacecraft rather than an assumption surrounding it. Apollo stops. Then Apollo rebuilds. When the program finally returns to flight, the command module looks familiar, but it is no longer the same machine. The tragedy remains permanently attached to it. The spacecraft sitting on the launch pad at the beginning of this story appeared to be humanity's path to the moon.
Begin sequence. Hatch open, pneumatic clear.
By the end, that image means something different. The sealed hatch is no longer a routine part of a test. It is a warning. A reminder that reaching the moon was never only about distance, rockets, or exploration. Apollo ultimately succeeded because it first confronted a harder requirement.
Over 1,400 changes were implemented following.
Before it could carry humans safely through space, it had to prove it could keep them alive on the ground.